Hello, everybody. It's hat day. Okay, so we are going to analyze a log function, but before that, we're going to analyze an exponential function. And it turns out that they're inverses of one another, and we're going to establish some fantastic relationships between these. So let's go. Okay, so let's start with a real difficult looking exponential function. All right, and I'll turn off this dotted line. All right, so we've got the exponential function 5 to the x plus 4 power minus 2. So it's been manipulated a little bit. It's a tough looking exponential function, base 5. All right, so the items in my analysis, well, take a look at my graph, exponential growth, okay? I usually expect to see it in the positive quadrants, and here we see most of it in quadrants 2 and 3. But let's see what that's all about. Table, all right? So my table shows me some of the integer coordinates, right? It's good to have coordinates that we can rely on, okay? So, and I'm just realizing that it'll be best to do the exponential analysis in one video and the log analysis in the next one, okay? So check it out. I'm going to show you how to evaluate with this. So for example, if I wanted to find g of 0, all right? In other words, the y-intercept, I'm going to say 5 to the 0 plus 4 power, all right? 5 to the 0 plus 4 power minus 2, all right? So I get g of 0 is well, that's 5 to the 4th, all right? 5 to the 4th minus 2, a simple little calculation, right? Well, 5 to the 4th is actually 625. And if I take away 2, I will get a y-intercept of 623. All right? So that's how you evaluate with the exponential functions. Your input is an exponent, and check out this output, 623. Okay? Let's talk about some other points. All right? So we have also an x-intercept here. The x-intercept is negative 3.569. Keep that in mind because we're going to find the inverse function. So important to think about intercepts. Y-intercept, it almost seems as if though you'll never get the y-intercept, but we actually just ran through the calculations. It's 0,623. So it's just on up there. All right, it's a very large y-intercept because exponential functions can grow very rapidly. Okay, the domain of any exponential function is negative infinity to positive infinity. All right, that is always true. Keep that in mind when we look at logs. All right, the range though is limited. If you pay attention to the range, you will not get a y value that is less than -2. In other words, this whole function is from -2 up. All right, you never get anything here. Okay, so the range therefore is going to be, and I'd have to stretch that out. It's going to be -2 to infinity, and we should write that. Okay, that's going to be -2 to infinity. Okay, and then that I mentioned right here, that leads us to a very important topic when it comes to exponential functions. Exponential functions contain what you call a horizontal asymptote. You've seen that rational functions, for example, have horizontal asymptote. Well, so do exponential functions. All right. So the horizontal asymptote of this function is y equals -2. All right. Because it is sort of like the floor of this function. It limits its range. All right. The values here on the left side get closer and closer to -2, but never reach it. All right. Which leads us to our next important point, the end behavior. All right. Your end behavior, well, as x goes to negative infinity, in other words, the left side, your y's actually go down to -2. Notice that the y's do not go to negative infinity. They go to -2. So that's a little bit different because this is flat on the left side. So as x goes to negative infinity, y goes to -2. On the right side, as x goes to positive infinity, well, your function is going to grow and grow. So as x goes to positive infinity, your y also goes to positive infinity. Keep all of these points in mind when you analyze the log function. All right. Last, transformations. So the transformations from the original function. Well, you notice that this had 2 transformations. All right. The +4 and the -2 will shift the original function left 4 and down 2. And that's a full analysis of an exponential function. The analysis of the inverse is coming right up. That's our time.